But my talk today is about the security of distributed ledger in an enterprise environment, and I did change blockchain to distributed ledger with intention because the systems and the platforms that I will be discussing are a bit wider than blockchain. So all you know that blockchain is a subset as distributed ledger systems. So I would like to talk about some broader range of systems and solutions that exist today. So as Vive mentioned, I'm CTO of ChainStack. ChainStack is a managed blockchain service for enterprises to run the protocols, to run the tooling around protocols, and to build decentralized applications. So the agenda for today will be quite simple. First, I will talk a little bit about the technology, what is distributed ledger, a couple of slides. Then how essentially security is today. So what if we take this technology in current state to enterprise? What kind of challenges we will see, and what are the potential solutions we see today and we can think about? So distributed ledger is a new paradigm when you don't have a central server and you have kind of mesh between clients and servers that communicate to each other. So clearly, for users and for programmers and for other actors in the system, it's quite new. It's quite challenging to understand sometimes. So we all need to understand that this is very novel and on different aspects like whether you use the system, whether you program the system, whether you secure the system, you should consider it as a novel system which we haven't seen before. There are different kinds of ledgers, and I really like this diagram because it's very simple. And ledgers vary from private to public, from permissionless to permissioned. And in essence, what influences the grade of ledger is who can write to the system and who can access the system. So the most open ledgers are definitely permissionless, public, which is Bitcoin, Ethereum, and others. But there is also place in the world for private permission blockchains or consortium permission blockchains. So these are all kinds of ledgers that exist today, and all of them are important in different scenarios and different use cases. So this is kind of to broaden the range of the discussion, not limiting it with only cryptocurrencies and public blockchains. So what was the promise of distributed ledger initially, and what is everybody talking about and claiming? So these are a few promises that distributed ledger had. That it's it's a distributed database, it's shared between the participants, it's append-only, it's immutable, and of course it's secure, right? So we use hardcore cryptography, we secure all the transactions, everything is amazing, and we don't lose our funds, and everything is very good. So what do we see in reality? In reality, for last 7 years, we see quite a lot of hacks, and the volume of these hacks is relatively big. So if you think about fraud in banking sphere, every year people lose roughly $15 billion in different kinds of bank fraud. So these volumes are not as big as 15 billion per year, but if we think about the value of cryptocurrencies and the value that they bring to the real world compared to banking today, we can say that they are really comparable, right? But if you take a look at the volumes of these hacks, they are quite significant. Keep in mind one number, which is 50 million on coin hoarder phishing campaign. I will talk a little bit about it now. So there's a great website on GitHub which explains and which accumulates all these hacks and tries to analyze like what are the root causes of these attacks. And if you take a look at this chart, it's clear that most of the reasons were not due to some very interesting smart contract vulnerability or protocol problem. So most of the root causes are very, very simple and kind of very traditional. There was a server breach. Someone took over some cloud account, or there was an insider, or there was application vulnerability just of the web application. So, so the last two, which is unknown, in this case, it's like smart contract vulnerability because they didn't have a separate category for that. And the second is protocol vulnerability or some cold wallet problem, which is definitely a minority. So this is very interesting to analyze. Like in reality, we all like to talk about like protocol vulnerabilities and what do we do with smart contracts to analyze them and to secure them. But in reality, the majority of problems are not in this space at all. So remember, I mentioned about Con Hoarder. So $50 million was stolen due to phishing campaign, and phishing is known for probably 30 years or something. And the problem was that the smart guys who initiated this campaign, they just bought a lot of Google ads with some blockchain.info website, which is quite well known to use as a web wallet. And they just planted a lot of phishing websites, and they use Punycode vulnerabilities and other kind of very simple tricks to trick users to upload their private keys, and eventually they stole 50 million bucks. So how secure is blockchain, guys? Now, what if we take this technology to enterprise with completely different requirements into security, privacy, safety, enterprise which is dealing with sometimes very critical data. Let's talk about critical infrastructure or any kind of businesses that do supply chain collaboration and so on. So these are some areas where distributed ledger can be applied, and these are some of proven use cases that have been analyzed as good use cases for distributed ledger. So some of the top ones are trade finance, digital assets, supply chain, logistics, food provenance, and so on. So essentially, wherever you need transparency of your transactions, wherever you need to automate your current state, which is a lot of paperwork, you can apply distributed ledger, and it seems to be a good application. It's not proven in all the industries yet, and there are very few production-grade blockchain deployments in enterprise, but it seems that these areas are the best areas to apply blockchain in the business world. So I'll talk a little bit about the differences between private, public networks, permissionless network. So for private versus public, it's quite easy. It depends on who can access the network. So if it's a private network, it's under a firewall, so you can't go and deploy a node and be in this network physically. So public network at the same time is something that you can go and access, download a Bitcoin node or Ethereum node or Zilliqa node and just go and mine coins and verify transactions and so on and so forth. There is this concept of hybrid blockchain, when you have a private blockchain or a consortium blockchain, which is a set of nodes distributed between different participants, which is some kind of connected to a public blockchain. And today, in 2018, this connection is quite naive. So it's like notarizing the transactions or notarizing the ledger state on the public chain. So it's quite substantial in some way, but in the same time, you can say that there's like true interoperability between private blockchains and public blockchains. But there is a lot of research on this, and there are a lot of companies who are exploring interoperability between these kind of blockchains. So hopefully, I personally am a believer of hybrid blockchains. I'm not a big fan of like anarchist Bitcoin, that everything should be on the blockchain, everything should be distributed. But at the same time, I don't like the concept of fully private blockchain because I don't believe that it makes sense. So I believe in hybrid blockchains when the majority of operations are offloaded to the private or consortium chain, but at the same time, all these transactions are secured by the public chain. So permissionless versus permissioned. I like this diagram a lot because it kind of explains what is the real difference. And in reality, when you have a permissioned network, you get a lot of speed because your transactions go much faster. But at the same time, you lose at other aspects, like you lose some decentralization of trust because you now can authorize some members to join the network and some not. You have less censorship resistance. Your network is less open. The transaction costs are also lower, which is also important for business scenarios with high volume of transactions. So these are some of the enterprise distributed ledger platforms which are quite well known nowadays. I would say these are top 5, but in reality there's probably 10 to 20. Some of them get more traction, some of get less traction, but these are more or less the platforms that are used nowadays. Now let's talk about everything around blockchain and inside blockchain. In reality, there is not only the consensus mechanism and networking layer and smart contract layer. In reality, there are much more actors in this ecosystem. There are much more components in the blockchain platform. If you want really to deploy it in a production-grade system, if you want to apply it to real-world business scenarios. So blockchain itself or distributed ledger itself does make sense if you don't input some data in there from outside. So essentially some system integration is required as well. If we're talking about business systems, there's like ERP, CRMs, etc. If we're talking about more like public use cases, these are oracles that input data in the system. So in reality, if we just deploy some blockchain, it doesn't make sense because it doesn't do anything useful. So so before we input some data there, it doesn't work. So it's a very crucial point in my opinion as well. And there are a lot of other components like, okay, we need to manage the systems. If we deploy a new blockchain for a business, we need to harden the infrastructure. We need to understand how everything is networked, how do we manage the access control and so on and so forth. So there are a lot of components besides just some basic building blocks of blockchain, which is consensus and the ledger itself and smart contract language. But there are much more on that if you want to build a really robust system which makes sense. I have some problems with my font, I think. Can you read, guys? Okay. So. So in reality, what is the status quo today of the enterprise distributed ledger system? So first of all, they're novel and they're quite complex. I think we all agree with that. Then we see a great oversimplification done by marketing and media of these systems that are super secure and they're super simple to apply, and you just go and download some private keys and then you're done and then you do transactions. So in reality, they are much more complex and much more effort should be put in place to make the systems really like working and make the system robust. So majority of the distributed ledger implementation and integration in the enterprise, they don't move to production. So if you Google now or you try to research like how many production grade distributed ledger systems there are now, there are quite a few, but not too many. So there is like a Walmart project that took some traction. There is another Hyperledger project that took some traction, but not that many. And it's very important to understand, in my opinion, that distributed ledger itself is just responsible for the integrity of transactions. So it's limited in terms of its security and privacy around the transactions, around the data. So it's just ensuring the integrity of transactions, not less, not more. And it's a great feature, but it's not everything that we need from the fully secure system, right? Then another interesting aspect that is derived from the fact that the systems are novel, that current security controls like access control, data and threat management, they might not apply to distributed ledger systems just because the nature of the systems is different to traditional systems that we got used to. And moreover, if we talk about permission networks, there are a lot of open questions that are currently being discussed and solved by many people, like who has the authority to grant permissions in permission systems? How will the system ensure that the validators are the people or companies they are? How should the IT resources be governed? How this shared IT should be managed by this multi-participant environment, how to deal with insiders, compromise nodes, and so on and so forth. So it's a lot of very interesting questions that have never been answered properly. So we, for instance, in ChainStack, we think about it a lot and try to understand this and try to build a proper design for that. Then I would like to talk about specific challenges for different aspects of the systems. So if we talk about blockchain platforms in kind of broad understanding, which is a protocol and also some infrastructure provider, so everything that actually runs a distributed ledger, we know that there are a number of different vulnerabilities and weaknesses currently that we can think about. So starting with protocol vulnerabilities, incorrect protocol settings. So you take some open source protocol, you configure it incorrectly, then you have vulnerabilities. So the protocol itself might be kind of secure, but then you configure it in a wrong way, and then it's unsecure. So configuration is very important. Infrastructure vulnerabilities. So what if you separate among tenants in a wrong way on the cloud provider? What if cloud provider that you run your nodes on is not behaving in the right way? So what if there is a data leakage between the nodes on the cloud provider? So obviously key management, right? So there are a lot of problems with key management. So what if your credentials are stored on some unencrypted storage and then they are stolen? So what if you don't store your key stores? This is very basic, but we still see a lot of this happening today. Information leakage to participant without permissions. Very important if you have a permission ledger. So what if you suddenly configured this ledger in an incorrect way again, so that some members have permission that they shouldn't have. Weak authentication authorization, also very basic, very traditional. What if you don't change your default API credentials for your system, for instance? Denial of service, also very traditional, very basic. What if you have a spike of transactions and your system is not ready for that? Data integrity issues. So what if you have a permission ledger again and you kind of rely on all of the nodes and one of the nodes is not available and you don't have high availability for this node and so on. So there are multiple possible vulnerabilities for the whole platform, including the protocol, but not limited to the protocol. Smart contracts, probably this is the most researched area and this is the most area that is being discussed. So I would not stop a lot on this. So these are like reentrancy problem in smart contracts, fraudulent function calls, and unintended execution results, and information leaks from transactions, and all kind of things that you can imagine. Then again, in this very novel space of distributed computing and distributed computing by smart contracts. Then we have decentralized apps. In reality, most of decentralized apps are just web apps. So if you take a look at the WASP top 10 vulnerabilities, most of them can be applied to decentralized apps as well. So this is very important to go through traditional security practices when you're working on the decentralized app. Weak secrets and personal data management. And honestly, we see that a lot when there is some decentralized app and there's like some browser local storage, and they store some secret material in that up to private keys. So we've also seen that. So this is not very unusual, especially when people who are building decentralized apps are not experienced developers. There are some also very fresh developers in this area, and they want to build exciting stuff, but they don't have this background that they understand how to build secure systems. So we see this quite a lot, especially in software like Exchange or Wallet. This is critical, and we've seen this in the exchanges as well. There are more issues on decentralized app, from regulation to privacy and compliance. So one of the interesting questions is like, how do you manage which data should be stored on chain, which data should be stored off chain, and this is usually managed by the DApp developer again. And this can be critical. What if you put some data on chain which shouldn't be there, and then it will be a big issue with GDPR or any other regulation, you name it. These are some basic issues of DApps. What about user endpoints? What about these guys who are actually using your DApp? So there's a lot of personal security and awareness that needs to be put in place, like with this example of phishing campaigns. Like obviously, there's a lot of space of improvement in this case. Also key management. Key management applies to almost each layer, obviously, because we deal with cryptography, we deal with the keys. So what if people are irresponsible in terms of storing their private keys? They lose it, they just put it on some cloud storage without encryption, etc. So there's a lot of issues with that. Malware infections. What if Trojan is stealing the keys from your machine? What What if the Trojan is hijacking the traffic is not encrypted, etc. All these traditional issues with endpoint security, right? So this is a framework that is suggested by Microsoft, actually, how to assess the cybersecurity of your blockchain. And I like it a lot because it's quite simple and it includes most of the areas that I talked about. So from user to a participant of a network, you go through it and you assess each step and you understand where you have attacker. You build your threat model in terms of the whole system and you understand what problems you may have. You build the reference architecture of your solution with the security in mind. So, the idea of my talk essentially was to broaden the perspective from just security of blockchain to security of blockchain-based systems and solutions, because they are much bigger than just building a distributed ledger. Also, very interesting quote that I read recently. Since most organizations looking to adopt blockchain applications likely won't have the technical experience entirely in-house, they use a third-party blockchain as a service will become required. So I totally agree with that, because today we don't build our own solutions under the table using our own computers that we build ourselves. We go to AWS and we deploy some nodes and it's great. So I think that ultimately, within some time, either 3 or 5 or 7 or 10 years, most of the people will not be using blockchain as just something that they download from GitHub. They will be using it as a service. So this comes to our ideas and our thoughts and our implementations of how security should be applied to blockchain and what we do currently in ChainStack to ensure the security of the systems that we build. So first, we start with the key management, obviously, because this is the most critical part. And we apply secure KMS and hardware secure model to store the keys. Currently, we look into HashiCorp Vault, which seems to be a good solution for our use cases. Then we also do network hardening. So we dedicate the networks that we deploy in terms of each ledger in each organization. We do a lot of traffic filtering, of course. We close the ports that we don't need. We harden images and containers that contain the nodes. So obviously all file systems are encrypted. We don't have system admin access. We don't have SSH access to the node, only API access and only when required. We do service-to-service security, obviously, so the connections between the services, between the nodes should be secured as well. We do persistent storage encryption. We do, as I mentioned, rigorous on-chain and off-chain governance design, because we need to understand how the shared IT will be managed, because it's critical in enterprise environment. And then again, it's very novel, because previously companies, they just manage their own resources. And now if we want to move to this, let's say, competition and collaboration between organizations, they need to manage the shared resource if they want to have the single point of idea of what is going on with their data between several organizations in a consortium. But this needs to be designed very well. Obviously, a multi-factor authentication for user accounts in the system. So what are the areas that we haven't worked on yet, but we're actively looking into? These are granular access controls, of course. Detailed ledger system audit, so including blockchain-based audit log. So what happened with your blockchain as a system? What kind of activities you saw in the system? And we are looking into building an audit log and probably building it on the blockchain as well, so that it can be tampered with. Obviously, systems monitoring, very extensive. Isolation of signing nodes to eliminate unauthorized access. It's similar to cold wallets, but in some blockchain, in some protocols, it's easier to have a dedicated node that will do signing, and you separate this node from all other infrastructure, so that nobody outside can access the node, and only the authorized users can access the node. Obviously, we're looking in the hardware security models. Like SGX for doing sensitive operations. Automated smart contract security audit. There's a lot of great tools today, mostly for Solidity, not that much for other languages and other frameworks. So we're looking into machine learning-based tools as well. So if anyone is interested in machine learning-based scanning of smart contracts and finding vulnerabilities, would like to talk to you. Quantum cryptography as well. For instance, using simple things like quantum random number generator for generating true randomness in our systems, also looking into it. And instrumented data privacy assessment to understand, for instance, which data should be put on chain, data shouldn't be put on blockchain. This is also one of the areas of research. So that's mostly it for today. Thank you very much. If you have any questions, I would be happy to answer them. If you're interested in some of these areas, I would really love to talk. And also, I have a small announcement. There is an organization called Crypto Explorers. And initially, these guys are from Switzerland. And they did this event in Switzerland when you go to Zurich and Zug, and there's a like 2 or 3 days event when they go to all the companies that are based in Switzerland, blockchain companies, of course, and they talk to them, and they have kind of roundtable discussions and so on. So a few months ago, I went to this program, and now these guys are coming to Singapore. So on 26th and 27th, they will be here, and there will be a program including Zilliqa and other guys like Indoors and Kyber Network and Chainstack as well. And they have a free scholarship program for PhD and postdoc students. So if anyone's interested, let me know, and I will give you a contact of these guys so that you can join the program if you're interested. It will be 2 days program just before Block Show conference in 2 weeks. So if anyone's interested, let me know. I will give you a contact of the organizers. Thank you very much. Are we open for questions or no?
Thank you for your talk. It's really interesting. So according to your categorization of the blockchain, you say there are permissioned and permissionless, and you show like eight kinds of use cases. But when I basically say that most of them are more suitable for permissioned blockchain rather than permissionless blockchain. So how do you say the future of both kinds of blockchain systems?
So as I mentioned, I see the future in hybrid kind of blockchains. When you have a permissioned blockchain, which is running in a consortium environment between a few organizations, but then they somehow secure this permission chain to a public chain and don't spend too much money on it, but ensure that this permission chain is secure enough by using public blockchains. Like the most naive use case is something that we explore. Like let's audit all the activity on our permission blockchain, for instance, on the public chain. For instance, this is one of the examples, but I'm pretty sure this can be extended to many other techniques.
Interesting, thank you.
I'm just curious, for the security audit, so you're looking at machine learning approaches, but would that be better than analysis approaches or verification? Or
that's a great question. That's why we're exploring it. So the first step of our research is to take existing tools, download all Solidity smart contracts, run all these tools, and figure out whether we can build a model that is better than all these tools aggregated together. So we don't know.
So it's not necessary.
Of course. Maybe it's not good, but we just research it just because we think it may be applied. Because there are like next generation code scanning tools like LGMT, which are using machine learning and data mining that seem to be quite interesting and good for some languages. So no, so only data science kind of things, or because they claim to use machine learning.
From what I could be wrong, but from what I see, it's mostly using analysis.
Right. Okay, but they claim to use machine learning, so we are yet to explore.
Anyway, it's using some kind of data log thing, so it doesn't usually go with machine learning.